Good morning, aspirant. In this video, you will be learning the term conductance on how many factors. On how many factors the conductance depends. It is a very much confusing question actually. There are many factors on which conductance depends, and it is a very question intense portion of conductance because students get confused here mostly. Okay, conductance. So conductance will have some dependence. On how many factor it depends and how that dependence is going on. Basically, we are going to discuss here conductance means it is basically electrolytic conductance, right? Electrolytic conductance, there are three type of conductance, in earlier lectures we have discussed. Now there are two major parameters, there are two major factors on which conductance depends. Two factor is, first, number of ions. Number of ions, more number of ions, more will be conductance. Second factor is mobility. Now you can now you can imagine that mobility means a single number of ions. Suppose two different system here, one positive charge, one negative charge. So this is moving towards this electrode, this is moving towards this electrode. Now if in both the cases mobility is different, suppose this is going slowly and this is going fast, so don't you think that this system will show more conductance? So mobility high means conductance high. But both will increase conductance. But first one is prominent. That means conductance increase with increase in ions will be much more than conductance increase with increase in mobility. That means number of ions is more prominent factor, okay, on which the conductance depends. Now, does the conductance depends on concentration? Because concentration is basically game of number of ions. Because we are going to discuss electrolytic system, we are discussing electrolytic system. Electrolyte means there will be ions in the system. So ions, more the concentration, more will be number of ions, isn't it? So with number of ions, one related dependence is of concentration. So let's see how concentration affects the conductance. So we are going to discuss the effect of concentration. Okay, two very important conductance term, one is kappa, one is lambda m. Specific conductance, molar conductance. How they are going to depend with concentration? Let's take an example, very easy example. I have two different containers. Here I have a solution of 10 liter. Here I have solution of 100 liter. Here I have added 1 mole NaCl. Here I have added also 1 mole NaCl. Now here concentration will be, in 10 liter there is 1 mole. In 1 liter it will be 1/10 mole. That means 0.1 molar concentration. Concentration will be 1 molar. And similarly here concentration will be 0.01 molar. Right? Now, what is the definition of kappa? Kappa is nothing but conductance of 1 ml solution. In this total system, suppose this box is 1 ml. Suppose this box is 1 ml. We know this solution is much dilute, but this solution is concentrated. Don't you think in this volume there will be more number of ions than this box? Because it is dilute solution, ions are far enough. So in this box there will be less number of ions, in this box there will be more number of ions. So more number of ion means more conductance. So kappa, suppose it is system 1, it is system 2. So kappa 1 is more than kappa 2, isn't it? Because in a 1 ml volume There are more number of ion in more concentrated solution. So that means concentration is directly proportional to kappa. That means in first one concentration high, kappa high. So kappa is directly proportional to concentration, right? Now lambda m. What will happen when there is a dilute solution? When there is a dilute solution, when there is dilute solution, cation and anion are not close. But in this system, concentrated solution, cation and anion are close. But in dilute solution, cation and anion are far enough. So when cation will try to move towards negative electrode, when anion will try to move towards positive electrode, when cation is going to move, then anion will drag it because they have a Coulombic interaction. So negative ion will stop this positive ion. Similarly, positive ion will try to stop this negative ion because they are close enough, right? So their interaction is high. But in dilute solution, the interaction is not so high because they are in very much high distance. So it has very less dependence or very less influence on another. So here fast it will move faster. So here mobility will be higher. Mobility will be higher. So mobility higher means conductance higher. That means in dilute solution, separation is more. Separation between ions is high. That means mobility high. That means lambda m high. Okay. So that means in dilute solution lambda m high. So for lambda m, this is basically proportional to 1 by concentration, isn't it? In dilute solution, that means concentration less. Here concentration is lower. Here concentration is higher. Where concentration is less, then lambda m is high. So they're inverse proportional. So overall, what we have concluded, be very careful about it. Kappa proportional to concentration, but lambda m proportional to 1 by concentration. But because you will get confused where, if you have not learned it, then you will be confused that both the things are conductance. This is also specific conductance, this is molar conductance, but the variation with concentration is different. I hope it's clear to you. Thank you.